Yeah, hello students, this is the fifth part of functions. So in last part I explained some important types of functions. The two important function is GIF, greatest integer function, important one. Sometimes this is called step function also. Why the name is given step function, I already explained. Its graph will be just like steps. So x is any real number, its greatest integer denoted by this symbol. So already explained everything about this nana. 2.1, step 2.1 2 only, step 3 equal to 3 only, step 0.41 equal to 0 only, step minus 2.41 equal to minus 3. So how I define, that is important thing nana. So x is any real number, then there exists integer n which is equal to this, so that n lesser than or equal to x less than n plus 1, such n is called greatest integer of x and denoted by this symbol. Everything I explained about this and properties also, but one important property about this, so many properties I explained. One important property is always x greater than or equal to step x, for x belongs to R. You could take any example and you can verify. So this is the important property. Just observe students, here already I explained some properties. You people can verify remaining properties 6, 7, 8, 9, 10. Up to 6 I explained. That is not big problem. But this is very important. Take x equals something 3.1 for example. 3.1 is greater than or equal to step 3.1, correct only, no? Because 3.1 greater than 3 only. So r equal to, when both sides are integers, then equality will hold, otherwise only greater, 3.1 greater than 3. Okay. So what I can say here, yeah, x is always greater than or equal to step x. This is the important property of greatest integer function. Like that, next fractional part of function is the fractional part of that also important. So I already explained this function in trigonometry. So again listen students. So listen all of you. Any real number, any real number x can be written as integral part plus fractional part. This fractional part should be positive. Okay, this fractional part should be positive. So any real number x can be written as integral part plus fractional part. Okay, this function is called fractional part of function. So I can say that f of x is called fractional part of x. You can read as fractional part of x. What is the value of this? That is important. What is the domain of this function? What is the range of this function is important. So x is any real number, but range is closed 0 to open 1. Only fractional output. Sometimes you will get 0, other than that the value is from 0 to 1 only. F of x equal to fractional part of x. X belongs to R. This is domain. Range is range. The range is closed 0 to 1. So I already explained. Again I want explain. So listen all of you. Any real number x, its fractional part denoted by this is the function, or I can say that f of x equal to this fractional part of function. Domain is all real numbers, range is close to 0 to 1, fractional part is all positive fractional part. Okay, how to draw its graph? That is interesting thing. Yeah, this is x-axis, this is y-axis. For example, this is 1, this is 1, this is 2, this is 3, this is -1, -2. So f of x equal to fractional part of x. If x equal to 0, so I can say y also 0 only, 0 comma 0 here. If x is taken as 0.1, y also 0.1 only, fraction part of 0.1, 0.1 only here, 0.2, 0.3, 0.4, 0.5, 0.5, so 0.99999 also 0.99 only. If x is taken as 1, important, fractional part of 1 is 0 only, because fractional part of 1 is 1.00, no, that is equal 0 only. That's why if x is taken as 1, your output is 0, y is 0 means here. So 1.1, if 1.1 equal to 0.1 only. So 1.2 given, what is that? 0.2 only. So what happened? X is taken as 1.1, your y is 0.1. X is taken as 1.2, your y is 0.2. So these are the ordered pairs. Your open circle at 2, at 1 open circle. Okay, students. So x is 1, y is 0. X is 0.9999, y is 0.999 only. X is 2, y is 0. X 1.9999, output is 0.9999. That's why we will get graph will be like this. This is the graph of fractional part of function. Already explained. It is a periodic function with period 1. Length 1, no, here length 1. So period is 1. This is a fractional part of function whose period is 1. 1 minute, I think here all these two should be open circles, Nana. That is important thing, open circle and open circle. Okay. What I explained is given f r to closed 0 to open 1, not closed 1, open 1, such that f of x equal to fractional part of x, 1 I plus f given, I integral part and f, and it is integral part of f and fractional part of k. So f should be like between 0 to 1. This is the definition of fractional part of x. After its graph, just I explain, no, again here something is given. Observe students, see here open circles, a thick circle. This is the graph of fractional part of function. Fractional part of function is a periodic function whose period is 1. Yeah, next trigonometrical functions. The functions involving trigonometrical ratios are trigonometrical functions. Students, here important note, all of listen, this is very, very important. So what is given? All the functions which are not algebraic are called transcendental functions. Transcendental functions, algebraic functions and transcendental, two types of functions are there. These are said to be transcendental functions because these all are not algebraic functions. This is trigonometrical function, logarithm function, exponential function. Okay, so trigonometrical functions are treated as transcendental functions. Okay, Ranana. So all the functions which are not algebraic are called transcendental functions. So now to trigonometrical functions. First of all, first function is f of x equals sin x. This is one of the first trigonometric function. So its domain is all real numbers, range is close to -1 to 1. This is the graph. Okay. Next one is cos function. This is cos function. Its domain is all real numbers, range is -1 to 1. This is its graph. Tan function. If cos x equals 0, tan is not defined. Cos x equals 0, what values of x cos x equals 0 should identify? The angles of the form 2n plus 1 into pi by 2. For x is equal to 2n plus pi by 2, cos x equal to 0. Except these values, tan function is defined. That's why tan domain is all real numbers except the angles which are in the form of 2n plus 1 into pi by 2. Okay, or you can write here domain. This is the domain of tan function. Range is all real number. This is the rough sketch. Next, cot x means something is given wrong here. This is not correct, Nana. Cos x by sin x. Okay. If sin x equal to 0, cot function is not defined. What values of sin x equal 0 should identify? So x should be in the form of n pi. Then sin x equal 0. So what is the meaning of that? Cot x should define if the angles which are not in the form of n pi. That's why domain of chord function is all real numbers except which are, angles which are in the form of n pi. Range is all real numbers. You should remember this graph. Already this concept we completed. So fourth after, fifth one is cosec function. Cosec means 1 by sine function. If sin x equal 0, cosec is not defined. So here sin x equal 0, chord is not defined. What is the condition for chord? That is the condition for cosec. What is the domain of chord? That is the domain for cosec. So same domain. So r minus n pi, n belongs to I, and range minus infinity to minus 1 union 1 to infinity. All these things we discussed in trigonometric nana. The graphs and everything is completed. We just need to remember. Secant x is 1 by cos x. If cos x equal 0, secant x is not defined. Cos x equal 0, tan x also not defined. The domain of tan x and secant x are same. That is r. From r we need to remove the angles which are in the form of 2n plus 1 into pi by 2, where n belongs to z. Here minus should be here minus. R minus 2n plus 1 into pi by 2, n belongs to z is the domain. Range is minus infinity to minus 1 union 1 to infinity. Okay. So everyone should remember all these basic graphs of trigonometrical functions and their domains and ranges. Yeah, okay students, the modulus function already discussion completed. Mod x, f of x equal mod x, its the domain is all real numbers. A range is what? Positive real numbers. So I can say non-negative real numbers, range is. Okay, what I can say close to 0 to infinity is the range of the modulus function. So its graph already clearly given here. So important notes students, here 2 important notes are given. Everyone should remember these 2 notes. What is the meaning of that? X square and mod x whole square both are same. One thing. And root over x square, don't cancel, that is wrong concept. So root over x square means mod x. Root over sin square x means mod sin x. Okay, root over x power 4 means mod x. Okay, mod x square. So that should becomes x only, that is not a big problem. The next exponential function. Yeah, okay students, so now I want to explain about exponential function. The function of the form f of x equal to a power x, where a greater than 0 and x is any real number, is called exponential function. What is a greater than 0? A greater than 0. A greater than 0 means two cases will arise for a. One is from a value can be taken from 0 to 1, another value of a can be taken from 1 to infinity. Okay. So this is called exponential function. So x is any real number. What is the meaning of that? Domain is all real numbers. Range I want, range, whatever be x, a power x is a non-negative real number. That's why I can say that open 0 to infinity is the range of exponential functions. And graph of basic functions important. So graph of exponential function is important. To draw the graph of f of x equal to a power x, I will take 2 cases, a is 0 to 1 and a is 1 to infinity. If a is belongs to open 0 to 1 and x is any real number, so then your graph will be like this. Decreasing graph, should remember like this. This is the graph of a power x. This is 0.1. 0, 1 means x is 0, y is 1, like that. So this is the graph of the function. This line never intersect the x-axis, but it is closer to x-axis. Means what happened? Your x values are more and more, your y value is tending to 0. Okay, this is the graph of exponential function for the condition a lies between 0 to 1. If you take a is greater than 1 case, so f of x equal a power x graph will be like this, increasing graph, this is decreasing graph. You can draw arrows like this, increasing graph. So everything you discussed in the concept of trigonometry and in basic inequalities also, this increasing graph, this is 0, 1. Okay, if x values are increasing, y values also will increase. If x is tending to minus infinity, then y is tending to 0. So these two are the important graph for exponential function, the basic graphs. Yeah, next logarithmic functions. Students, logarithmic functions. Here also everything is discussion completed. F of x equal to logarithm of x to the base a. X should be greater than 0, a should be greater than 0, a not equal to 1. Under this condition, here this function is called logarithmic function. So domain means x is what? X is open 0 to infinity is the domain of the logarithmic function. So range is all real numbers. So again you need to draw the graph of logarithmic function. You need to take two cases. One of the cases is a from 0 to 1, another case is a greater than 1. Okay. So anybody have any doubt about these graphs and this domain and ranges, please watch again basic inequalities videos. I explained everything in basic inequalities videos about logarithmic functions and exponential function, how to find their domains and ranges. Okay. Logarithmic functions. Okay. This is the graph of logarithmic function under the condition your base is from 0 to 1. So this is decreasing graph. If your base is greater than 1, you will get a graph which is called increasing graph. Total nature of the logarithmic graph I explained in basic inequalities videos. Anybody have any doubt about this concept, please watch those videos again. Okay. So this is about logarithmic functions. Students, these are a few important type of functions. Some more types are there. Before that, I want to solve some simple problems. So first problem, find the domain of the following functions. Clearly explained what the meaning of domain of the function. See here, f of x is a function. So for example, x square or something. Domain and range. I explained what is the domain and what is the range. What values of x? X square is a real number. Because our functions are all real functions. What values of x? X square is a real number. What values of x? F of x is a real number. Such x values are called its domain. First thing. After finding domain, substituting the domain values in the given function, your outputs will get, those outputs are called range. So domain means inputs. So first function, students, f of x is equal to x square plus x plus 1 given none. No fractions, nothing, no. Whatever be x square plus 1 is a real number only. I will write for every x belongs to R, x square plus x plus 1 belongs to R. Therefore, domain equal to all real numbers. So here he is not asking range, na? Only domain. Range is difficult, we will discuss later. Here just he want only domain. I want find domains only. Second problem, f of x equal to 1 by x. Students, listen, what values of x? This is a real number, should identify. X equal to 0 is not a real number, except that it is a real number. That's why domain, directly I can say that domain equal to all real numbers except 0. Third problem, where is it? Here. Yeah, f of x is equal to 1 by 2x minus 1. If this equal to 0, then this is not a real number. What values of 2x minus 1 equal to 0 means, I can say that x equal to 1 by 2, that's why all real numbers except 1 by 2. This is the domain of the function. Yeah, 1, 2, 3 problems completed. Students, listen now. Yeah, third problem. Third also completed, I think. Fourth problem. F of x is equal to 2x plus 3 by x square minus x plus 1. Interesting problem this one. Yeah, numerator okay, Nana, 2x plus 3, but denominator only problem for us. If x square plus x plus 1 equal to 0, then this fraction won't define. If x square minus x plus 1 equal to 0, then f of x is not defined. First of all, you want to identify such x values. Means what values of x? X square minus x plus 1 equal to 0. Several times I explained in a basic inequality, x square minus x plus 1 is, shouldn't this is can be written as x square minus 2 into x into 1 by 2 plus 1 by 4 minus 1 by 4 plus 1. Just what I did, Nana, So here I multiplied 2 divided by 2, I added 1 by 4 and subtracted 1 by 4 because I want to make it as a perfect square. X minus 1 by 2 whole square plus 3 by 4. So this is the expression. Observe all of you, x plus 1 by 2 whole square non-negative. But this non-negative 3 by 2 added means the minimum value of this expression only 3 by 4 to infinity. That's why this value never 0, nana. That means x square minus x plus 1 never 0 means domain of the given function is all real numbers. I will write that. So x minus 1 by 2 whole square 0 when x equal to 1 by 2. Other than that, greater than 0 only. So belongs to closer 3 by 4 to infinity. Therefore, x square minus x plus 1 never 0 for every x belongs to R. Whatever makes it is not equal to 0, nana, because the minimum value is 3 by 4, no? Minimum value is 3 by 4 to infinity. Therefore, domain equal to all real numbers. Domain is of the given function is all real numbers. Fourth also explained. Fifth is interesting problem, students listen. F of x equal to x square plus 1 by x square minus 3x plus 2 is given. I want find the domain. What values of x? X square minus 3x plus 2 equal to 0. That should identify. If x square minus 3x plus 2 equal to 0, then f of x is not defined. So what values of x happens? We need to identify. X square minus 3x plus 2 is nothing but x minus 2 into x minus 1. Observe now. That is, if x equal to 2r1, then f of x not defined. Students, x square minus 3x plus 2 factors are x minus 2 and x minus 1. X equal to 1, this is will vary, it equal to 0, x equal to also 0, means all real numbers you can take instead of x except 2 and 1. Therefore, domain of the function, domain of f equal to all real numbers except those two, 1 comma 2. Okay. So this is the domain of the function. Which one? Yeah, fifth one. Students, anybody have any doubt about finding domains and inequalities, Weierbeker method? Please watch my videos. Okay, basic inequalities videos by VGR. From that you will get correct information. Sixth problem, f of x is given as root over 2 minus x, just like y equal root over 2 minus x. What values of x, y real, that is called domain now. So in under root is this should be greater than 0, then only y is a real number. 2 minus x should be greater than r equal to 0. 0 also no problem, no? If x is 2, this total is 0, y equal to 0 is a real number only. X minus 2 lesser than or equal to 0, or x lesser than or equal to 2. What is the meaning of that? Your x should be 2 or less than 2, then only y is real number. So dom, I can write domain of f equal to minus infinity to closed infinity. So this is the answer for the problem number 6. Nana. A seventh problem, f of x is given as root over 4 minus x square. What I can say, y equal root over, x minus 2. That is not seventh problem. Okay. X minus 2. Okay. Y equal root over x minus 2. Now I want to identify what values of x, y is real number. So this should be greater than or equal to 0. X minus 2 greater than or equal to 0 implies x is greater than or equal to 2. Therefore, domain equal to, closed 2 to infinity. All real numbers from 2 to infinity will satisfy. Student, seventh also explain, Nana. Eighth problem now. F of x equal to root over x square minus 4 or y equal root over x square minus 4. What values of x? y is real, means x square minus 4 should be greater than or equal to 0. Under root is there, no, greater than or equal to 0. Or x plus 2 into x minus 2 greater than or equal to 0 minus 2 to sign scheme, this is sign scheme method. So I already explained in basic inequalities, greater than symbols you want. So domain equal to minus into minus 2 closed union closed to infinity. Students, once again listen, without basic inequalities concept we can't solve this type of problem. Directly I am explaining here how you got this line, real number line, how you got this result. So you people must watch that basic inequalities by VGR, otherwise you people can't understand how I am getting all these results. Okay, 8th completed. Next 9th problem. Yeah, f of x equal to root over 4 minus x square or y equal to root over 4 minus x square. So what values of x, y real number means your 4 minus x square should be greater than or equal to 0. To use wavy curve method, x square coefficient x coefficient should be positive. That's why I am multiplying minus another side, x square minus 4 lesser than or equal to 0, or x plus 2 into x minus 2 lesser than or equal to 0. Now I want to use sign scheme here, number line minus 2 plus 2 plus minus plus negative symbols you want. So directly I can say the domain of the function equal to closed minus 2 to closed 2. Okay students, where is that? Okay, now 10th problem, f of x equal to 1 by x minus 2 root over 1 by root over, that is interesting thing. So y equal to 1 by root over x minus 2. So y should be real number. What values of y is real number, that is called domain. Your x minus 2 should be greater than 0, not equal to 0 also. If x minus 2 equal to 0, 1 by 0 not defined, that is not real number. That's why x minus 2 should be greater than 0. X should be greater than 2. Directly I can say the domain equal to open 2 to open infinity. This is 10th problem completed. Yeah, next 11th problem. F of x is equal to 1 by root over 2 minus x. So here also y equal to 1 by root over 2 minus x. So 2 minus x should be greater than 0, or x minus 2 less than 0, or x less than 2. Therefore domain equal to minus infinity to open interval. This is problem number 11. Okay students, 11 completed. So I want to explain 12 now. 12. Where is that here? F of x is equal to 1 by x square minus 4 root over, or y equal to 1 by root over x square minus 4. So what is the meaning of this? X square minus 4 should be greater than 0, only greater. So x plus 2 into x minus 2 greater than 0. So I already explained how to solve this, plus minus plus greater symbols you want. 2 won't include, minus 2 won't include, open circles. Therefore domain equal to minus infinity to minus 2 union 2 to infinity, all open brackets. In this way you can complete. Now I want to explain this, remaining easy only for you people can complete. 15th problem, f of x equal to logarithm of x is given. For example, only log x is given, your x should be greater than 0, that's all. So what I can say, domain is open 0 to infinity. But in this problem here modulus is given, that is interesting thing. Indirectly given, this is non-negative. So if x equal 0, log 0 not defined, no, except 0 everything it will define. For example, instead of x I wrote minus 2, log of mod of minus 2 means 2 only, no, log of 2 is defined. That's why just all the real numbers except 0. So logarithm of x to the base e different na here. Mod is given, that is interesting thing. What is the meaning of this? Domain, directly I want a domain, all real numbers except 0, Okay. Next 16th problem and explain students, 16th is interesting. Yeah. F of x equal to 1 by step x. Clearly given here. Denote GIF, greatest integer function. What values of x step x equal to 0? That should identify. Y equal to 1 by step x. If step x equal to 0, then f of x is not defined. No, we want to identify what values of x step x equal to 0. Observe all of you. Step 0 what nana? 0. Step 0.1 what nana? 0. Step 0.2? 0. Step 0.99999 0 only. Step 1 1. I think understood. What happened? Your x value should be closer to 0 to open 1. For those values of x, step x equal 0 only. I will write if x belongs to closer to 0 to open 1, then step x equal to 0. Except these values, the function is defined. So, domain all real numbers except the values from 0 to 1 should be removed from that. Okay, sometimes you can write this another way also. This real number line closer to 0 to open 1. These values should be removed. These values should be removed from all the real numbers. Remaining values are said to be the domain. So, minus infinity to 0, union 1 to infinity. Okay. Domain equal to minus infinity to 0 open, union closer 1 to infinity. This is the domain of the function. Problem, interesting problem. F of x is given as 1 by logarithm of 2 minus x, plus root over x plus 1. Just like f of x equal to k of x plus L of x is given, I already clearly explained. To find the domain f of x, we need to find domain of k of x first, domain of L of x, their intersection gives the domain of the total function. Okay. So, 1 by 1 I want to find 1 by logarithm of 2 minus x is given. I want to find domain of this function first. Its domain. What? 2 minus x should be greater than 0, one condition. And 2 minus x should not be equal to 1, second condition. Why 2 minus x should not be equal to 1? That is interesting thing. Log 1 0, 1 by 0 not defined. That's why 2 minus x should not be equal to 1. And logarithms are defined only for positive real number. That's why your 2 minus x should be greater than 0. Okay, students. So, first of all, we need to identify what values of x this happens. X lesser than 2 and x is not equal to 1. So, what happened? Take number line here 1, here 2, x less than 2, x less than 2, x less than 2 and not equal to 1, not equal to 1. What is the meaning of that? X belongs to minus infinity to 1 union 1 to 2. This is the domain for the first function. Next, I want to find domain for second function. This is first one I can write. This is second one. What is that? Root over x plus 1. What is the domain? Directly I can say that your x plus 1 should be greater than or equal to 0. So, what is the meaning of that? X should be greater than or equal to minus 1. Means x belongs to closer minus 1 to infinity. So, now you want to find intersection, domain of given function. So, take number line, students. What is the domain of first one? Minus infinity to 1, 1, here 2 is there, minus infinity to 1, 1 to 2, 1 to 2, something I think, okay, correct only. Yeah, minus, except this, these values are taken for the first function. What second function in that? Minus 1 to infinity, minus somewhere here minus 1 minus 1 included, minus 1 included, minus 1 to infinity. So, what is the intersection with this portion intersection? This portion intersection, therefore, domain, I can say domain of the function equal to minus 1 closed to 1 open, union 1 to 2. So, this is the domain of the given function.